Humans are changing the Earth in profound ways. But how does this differ around the world, and how has it changed over time? Mapping the effects of human pressure on a global scale is a significant undertaking and requires a lot of data and complex modeling of numerous types of human pressures, such as roads, agricultural areas, and more. What if we could produce more up-to-date maps that can also be updated easily? I'm Pat Keyes, lead scientist at the School of Global Environmental Sustainability at Colorado State University, working with my collaborators, Professor Elizabeth Barnes in Atmospheric Science at CSU, and Professor Neil Carter at the University of Michigan School for the Environment and Sustainability. We developed a new way to explore this question, presented in our new open access article in the journal Environmental Research Letters. We developed a near-present global-scale human footprint index ranging from 0 to 1, using recent satellite imagery from the long-term Landsat mission and a form of machine learning called a convolutional neural network. Essentially, we train a deep learning algorithm to identify patterns in a set of satellite images and cross-reference those patterns with previously existing data on human footprint results from the same area and time frame. With repeated training, the machine learns what visible patterns in the satellite image, like a road for example, correspond to different values of the human footprint index. After enough iterations, the algorithm can accurately predict the human footprint index of new areas with images it has never encountered before based on satellite imagery alone. Machine learning is often considered a black box, a mysterious process where it's difficult to know exactly which pieces of data are influencing the algorithm's decisions. However, our team used an approach called layer-wise relevance propagation, or LRP, which lets us peer into the algorithm's thinking process. So, for example, let's take a look at the southern tip of Sumatra. Here we see the 2000 satellite image, and here is the corresponding prediction of the human footprint. Now we can see that in 2019, the prediction looks like this. What gives? It turns out that the model was able to successfully interpret what a road looks like and recognize that a new road now passes through this part of Sumatra. We employed LRP in multiple locations to uncover how the neural network made its decisions in different landscapes, and we feature some of these in the article. Just like a person, the neural network is not perfect everywhere on the planet, but in general it does a very good job, and its ability to be updated with satellite imagery alone is a game changer. This near-present human footprint index is a powerful tool, since it provides an unprecedentedly up-to-date view of how humans are affecting the planet. We use this information to interpret progress toward the United Nations Sustainable Development Goals, a set of 17 goals that aim to address all aspects of sustainable development for countries around the world. We focus on SDG 15, Life on Land, which is focused on terrestrial biodiversity conservation. We explore locations with substantial increases in their human footprint index and look at whether these areas are on track or are not on track to achieve SDG 15. Surprisingly, we find that of the 119 countries globally that are experiencing increased human pressure, 36% are also making some progress toward SDG 15. That some countries can simultaneously be progressing toward sustainable development goals while experiencing dramatic increases in human pressure confounds expectations. In this paper, we explore the spatial characteristics of how increases in human pressure actually unfold in different countries. In this work, we are excited about three things. First, that this research can now be used by the community that is understanding human pressure on the land surface. Second, that we can update this index as soon as new Landsat satellite data is available. And third, that we can contribute to near-present monitoring of progress toward a more sustainable future.